Hello and welcome. I'm Adam. This is Orbit at a Tilt, the science show where I try to break things down into easy and fun chunks. So, what are we talking about today? Today we're going to be talking about the latest discovery by the Curiosity rover on Mars. You probably heard about it, but what does it mean? So we're going to talk about that. I'm also going to tell you a little bit about Discovery a little bit about Curiosity and how we got to where we are in that mission and where NASA plans to go from here. So, let's take it away. And as I go, please don't hesitate to put questions in the comments. And if you are liking the broadcast, share it out to your friends. All right, let's take a look at Curiosity. Now, the first thing I want to do, we're just going to look at the rover itself. Now, I'm trying some new things here, so if anything goes wonky, let me know. You can hear me now, right? I hope you could hear me before, but all right. So this is the Curiosity rover. It is about the size of a small SUV. It is 10 feet long, 9 feet wide, 7 feet tall, and it has a mass of 1,982 pounds. So you can see it's made up of a main body here. Can you see my pointer? Okay, so it's got 6 wheels, 3 on each side, main body, camera. And then if we zoom in, here is the drill area. It has all kinds of scientific information. The official name of this mission is the Mars Scientific Laboratory. Curiosity is actually a robot science laboratory, which is pretty cool. The drills are here. These are all scientific instruments, geology instruments. So what happens is Curiosity will drill, get a sample of the material, and it'll put it into one of these other scientific instruments for analysis. If we look at the other side, we can see this is the arm. The arm extends to about 7 feet. And let's see if this will... No, that won't zoom in. But this has a hand. It has a brush and a drill. And then all these instruments here. By the way, this is all at mars.jpl.nasa.gov. If you go to nasa.gov and look for Curiosity, you'll see it. They have it very prominently on their website. All right, now looking at the top, we've got all kinds of stuff here. They did can you see? Oh, my pointer keeps going away. Where is my pointer? Okay, well, over here on the... Maybe I can move myself. I'll be the pointer. All right, so send your name to Mars chips. Those were people sent in their names and they were engraved on this thing to send their name to Mars, which is kind of fun. There's a sundial. These are more of the science instruments here. The high gain antenna is how Curiosity communicates back to Earth. Low gain antenna it uses to communicate with... There are a couple of satellites in orbit around Mars that collect information from the rovers on Mars and send it to Earth in packets. Curiosity is not the only rover on Mars. Opportunity is still going strong. All right, and in the back, you'll see that there are these 2 cameras oh, there we go, sort of. All right, these 2 cameras here. That's what the rover drivers use to navigate the rover. This is a kind of a slow process. They have to plan their route because they give the rover instructions and it moves, a little bit, and then they give it more but they have to wait for the signal to come back and then make sure everything's okay and then move a little bit more. And there's quite a bit of a delay. And it varies. The delay varies depending on where the satellites are in orbit and all that kind of stuff. So, if we ever get a human in orbit around Mars, then these kinds of rover experiments could probably operate much better. All right, let's go back and take a look at some more. All right, so the ChemCam has a laser, and it zaps. I don't know where it showed the laser, but it zaps rock with the laser and then analyzes the chemical signature of the vapor that results from the zapping. The nav cams, those you can probably guess, are to help the drivers navigate. The mass cams, that gives us kind of what it would look like to us, like a rover's point of view. Okay, and we're back to the beginning. Now, the cool thing is the rover is able to take a selfie of itself. Check this out. It has. You notice you're not seeing the full mast. I mean, the full arm. Okay, because that's what has the camera that it's using to take this selfie. But that is a selfie of the rover, of the Curiosity rover, on the surface of Mars. And the detail is quite amazing. I mean, you can zoom in. It's quite high definition. Oops, I didn't want to select. I wanted to move. Check out the detail in the rocks there. Very interesting for scientists to see this kind of rock formation on Mars because do you notice the layers? That indicates the presence of water sometime in the past because the water would lay down these layers of sediment that would then turn into rock. So that's exciting. By the way, Curiosity's mission was to... Whoops, sorry. I'm trying some new things and it's not going as smoothly as I hoped. But we're going to roll with it. All right, so Curiosity's mission, science mission, was to find out if Mars ever was habitable to life. If life could have possibly ever lived there. It's already accomplished that mission. And it's now in an extended mission to do some more thorough investigations of Mount Sharp, which is in a crater called Gale Crater. And NASA and JPL made a cool video to show you what Gale Crater looks like and why we are so interested. So let's take a look.
We're flying in towards Mount Sharp, located in the center of Gale Crater on Mars. And to give you a sense of scale, Gale Crater has the diameter of the big island of Hawaii, and Mount Sharp is taller than the highest mountain in the lower 48 United States. As we descend to about 500 feet, we're going to be seeing some of the terrains that Curiosity has been exploring. To begin with, we're going to look at Yellowknife Bay, which is this arcuate rim of rock, a little cliff there, and that's where she discovered clays and an ancient habitable environment on Mars. But we had to drive there from where we landed, which is this mound-shaped hummocky terrain that was safe, and you can see how it's flatter. We landed right in the middle of that. Now, in late 2013, Curiosity is driving her way through this terrain. It's kind of etched and rough and rugged. On the left, we also have a field of dark-colored sand dunes, and we're trying to find a place where there's a gap in the sand dunes because we don't feel it's safe to cross over the sand dunes with the rover. We'd rather do it on hard rock. We would guess that sometime towards the middle of 2014, we will arrive at this place where there's a break in the sand dunes.
Okay, so obviously this is an older video because we've already passed this point. You can go, these sand dunes are amazing. There are incredible images of these sand dunes that are taken from the Curiosity rover as well as the Mars Reconnaissance Orbiter. You can go to NASA's website. NASA's images belong to the American citizens, so they are in the public domain, so they belong to you. So take advantage of that. Just go browse through those. You'll be amazed. All right, let's continue.
It's a place that's special to us because it represents interesting geology, and the topography is also interesting. We call it Murray Buttes, named after Bruce Murray, who was a pioneer in the field of planetary geology. When you look down here, you can see all these small buttes and mesas, and each one of those buttes is about 5 to 10 meters high, and each one of the buttes is about the length or width of a football field. You can see that sort of valley that goes through the middle of them there. And that's where Curiosity will wend her way through this rough terrain, we hope making interesting discoveries, and most importantly, signifying the transition between the first half of the mission, which was exploring the plains we landed on, and the second half of the mission, which is exploring the flank and climbing up Mount Sharp.
All right, so that gives you an idea of what Mount Sharp is and what Gale Crater is and why we wanted to send the Curiosity rover there. And the amazing thing about this rover is it's gotten beaten up. It's got some problems. Some of the wheels are breaking down, but it's still chugging along and doing some great science. They've had to modify the way they do some of the drilling because of some problems they experienced with the drill a few years ago, but they solved that problem. And we are just continuing to find more evidence of the possibility of a habitable Mars at some time in the past. So this discovery that they made on last week, the Curiosity rover is finally able to drill into rock again because they solved the problem that was preventing it from, well, they created a workaround. It was kind of creative, actually. They added a percussion to help it break up the rock. So they were able to sample rock that was exposed at the bottom of Mount Sharp, which is billions of years old, I think about 13 billion years old, and analyzed that rock, vaporized it, and used the equipment on the laboratory to analyze it, and they found organic compounds. So what does that mean? Organic compounds are compounds that contain hydrogen and carbon. You might have heard them called hydrocarbons. They're usually called hydrocarbons when we're thinking about fossil fuels like oil and natural gas, because all of that is organic material. Okay, remember, oil and natural gas, they came from the remains of living plant life millions of years ago, hundreds of millions of years ago. So the presence of these molecules, or these compounds, the presence of these compounds doesn't indicate that life, but it does indicate that the ingredients for life were there. So we know that wherever on Earth we have found liquid water, a source of energy, and organic compounds, we have found life. So far on Mars, we have found evidence of all of those now. So does that mean there's life on Mars? Does it mean there ever was life on Mars? We don't know. That was not Curiosity's mission. Curiosity's mission was just to see if it was possible. So what's coming up next? Oh, by the way, organic molecules had been found on Mars previously. So this was just another affirmation. That was in much shallower rock that was much younger. So this shows, that it's in the much deeper rock. Shows that, these have been on Mars for a long time. Plenty of time to evolve into a life of some sort. So, what's next? NASA is preparing the Curiosity 2020 rover, which is based on the Curiosity rover with a few different science instruments swapped out. It also is going to include a helicopter, which I think is amazing. The feat of engineering to make a little helicopter, it's small. I mean, it's like a little, it's just small. But imagine what that would open up in terms of exploration. You wouldn't have to worry about navigating these rovers over this rocky terrain. You could fly over and, that would be great. I'm really excited for that. And it's a real challenge because the atmosphere on Mars is very, very thin. So to generate lift enough to carry whatever is needed to make that a useful tool, that's pretty amazing, and I'm looking forward to seeing how that works. Okay, that's about it for Curiosity. Now there are a few things for in space history this week that you might want to take note of. Tomorrow is the anniversary of the Pioneer 10 spacecraft leaving the solar system in 1983. That was one of the ones that had the record, I think. It also is the anniversary of the Hayabusa spacecraft that retrieved a sample from a comet. That was a Japanese space agency mission. Retrieved a sample from a comet and brought it back. Now that one had some complications, but it still was able to return a sample, which was cool. All right, and new moon is tomorrow night. Good time. So dark skies should be. If you have clear skies, good night to look through a telescope at things like the Orion Nebula in the belt of Orion, or Jupiter. Jupiter is a great target. Saturn, if you're up, I think Saturn comes up. I can't remember now. Anyway, that it'll be up. Mars will also come up, and you can look at Mars through a telescope, but it looks like a fuzzy red dot, so I wouldn't really bother. On Saturday evening, Venus, which we've continued to see in the west, just after sunset, the moon is going to be nearby on Saturday. So a little crescent, little baby crescent will be there. So that should be pretty to look at. So remember to take a look at that. Okay, great. Thank you for stopping by. I hope this was... I hope I was able to kind of break down what the discovery meant and what it wasn't. I don't know. Tell me if you're still confused about that. I see people saying all kinds of things everywhere, but basically it's just another confirmation that life was once possible there. So until we meet again, don't forget to look up, and please remember, consider becoming a sponsor of the show. I really want to take this show to the next level and show you some really cool stuff. I'm right in NASA's backyard here in Houston. So with your support, I could do some pretty awesome things. Okay, I will see you again next week. And go out tonight and find Jupiter. It'll be in the west after sunset. Okay? See you next week.